So now we move on to this chapter Multilib, which was mentioned in the introductory notes. So there's a whole chapter about this. So it's obviously important if I need to have a whole chapter about it. So what is Multilib? It's essentially the ability to at least execute software that's built for another architecture different from your own. For example, the most common user of a 64-bit CPU that's wanting to execute software built to run on a 32-bit CPU. To better establish its terms, there we are. It explains each of those. That terminology it's used is 64-bit and 32-bit. IX6. Oh yeah, well, X. Yeah, so that's the original 3 or 4 generations of the 32-bit. In fact, I think x86 is more of a Windows terminology. I think in the Linux world, it's been called i386 generally, and more specifically i686. So, but I suppose that's good mentioning that there, because anybody coming from Windows would probably be more used to seeing that. Multilib can be achieved by first most having the hardware capable of x86 emulation, and then having libraries built for x86 emulation. We'll get into how to compile x86 libraries and 32 and software and their execution later on, but know the general process for LFS and BLFS is almost always compile software, and that's what we'll be doing. Yeah, x86 is quite a mouthful. There's lots of consonants in there, so I'll try and call that 32-bit and try and call this 64-bit where I can. It's just easier to say. So if I say 32-bit there, you know why, and if I say 64-bit here, you'll know why. It's worth noting that when the term multilib is used throughout the book, it's referring to running i686 instructions on a 64-bit host. This does not cover running other 32-bit architectures on the 64 extensions like ARM-HF and ARM64. Well, again, is it really referring to i686? i486 32-bit is still supported by the kernel and glibc and GCC, so I would say it's probably not really referring to i686, although you're not probably going to be running anything useful gaming-wise on anything less than i686 anyway, but I thought I'd make that distinction there. Am I capable of multilib? So if you're on a 32-bit CPU, you're not capable of multilib. Obviously, you cannot run 64 bits inside a 32-bit address space or register space. However, the other way around, if you're on a 64-bit CPU, you are capable of 32-bit emulation, then you're capable of multilib. So that's actually what the LSCPU line is about. I wasn't sure about this, but I'm thinking to myself, since I mentioned this in a previous video, that this is what the CPU is capable of. It's not what the kernel is exposing. So it shows that the CPU is capable of running 32-bit code. So run uname -m to find out if you're on a capable CPU. If the output is 64-bit, you should be capable. Well, we know we are because we've just built Multilib LFS, and it was tested limitedly, admittedly, but it worked. If you have a CPU that's capable of multilib, it's time to decide whether to go for it or not. Depending on circumstance, it may be necessary to go for it. Most gamers would not know this for Steam unless they wish to put a limit to the game they play, but many Steam's games are 32-bit. Some games are no longer receiving updates, or some are being updated but are still 32-bit to this day. So if you have a 32-bit CPU, you can skip the 32-bit binaries and compile everything normally as they're built for your architecture. Well, that makes sense. It says here Steam will eventually kill off 32-bit support. So yeah, eventually it won't be possible. And Wine, unlike Steam, Wine does not require the F32-bit libraries or i686 W64 Ming W32 toolchain. Moreover, to get multilib support in wine, it must be compiled twice, a W64 and a W32 with 64-bit build. However, as discussed earlier in the Steam section, that many games of 32-bit are no longer maintained or will take a while to switch to 64-bit. This is the case with Windows applications as well. So this means if you do a 64-bit only build, you'll lose compatibility for those 32-bit applications. A Wine WOW64, so I believe that stands for Windows on Windows 64, can run 32-bit and 64-bit applications. Build is recommended. If you do not have a 64-bit CPU, then only follow the 686 build instructions. Likewise, if you have a 64-bit CPU, then you can follow only the 64-bit build instructions. The Ming W64 toolchain is also really helpful for developers. So if you don't want full support with Wine but want full support with Ming W64 toolchain, then by all means go for it. So basically, this is how I built it. I built Wine with full 32-bit support, and I built it with the Windows on Windows 64-bit support, and that is what is recommended. So achieving multilib, on many distros, getting multilib support is very straightforward. There exists a guide that can act as a replacement for LFS. Compiling configuring a system that can boot, run and compile software, and also have the same ability with 32-bit. It acts to form the basis of what will allow you to follow any instructions laid out in the Steam Wine chapters. And such a guide there. And you can render MLFS if you wish. So I was going to mention this, that I would imagine it would be possible to take any multilib distribution and just adapt it to put GLFS on it, but I think that kind of defeats the point of what Linux from Scratch is all about. It's a short circuit really, so I would say build MLFS if you're thinking about it, which way to go. Build MLFS first, you'll get the experience of that, and then come back and do GLFS. So it says to render MLFS. It tells you how to do it here, as it did in the MLFS book, or on the main MLFS web page probably. So we're not interested in that because we've already got MLFS running. That's what's running here. And there's just some more information there about doing that. Furthermore, read which instructions to follow to find out which instructions to follow. So we'll be coming to that, I believe. Yeah, we do. Package config personalities. The package config compilation in the Multilib mirror does not cover package conf personalities which are needed for Meson toolchains. The package conf personalities allow for package conf to be run without having to specify the package config path. So we need to create these as the root user. So let's do that. So we need to copy all this in. So you can see it creates these files with these configuration parameters in, if you like, these two files. And as a root user, create symlinks to enable package config to find these personalities. And then it says now verify that the 64-bit package config is using the right personality. So let's do that. And the result should be triplet x684 sysroot dirt. Yep, that looks fine. Then verify the 686 package config personality. And it should look like this. So yes, that looks all correct. So that's good. So that's the start of our GLFS really. Meson toolchain files. Most applications rely on Meson build system, have decent support for cross-compilation, i.e. compiling 32-bit binaries and 64-bit system. It can be as easy as setting up the CC, etc. variables before using Meson setup to compile 32-bit binaries on a 64-bit system. However, some projects are more complicated for many different reasons, leading to the necessity of Meson toolchain files. They specify compilers options that should be invoked. The package config binary rather than symlink that uses certain personality file to use, LLVM config to use, etc. This is required for many Meson projects, especially if you followed the BLFS book before this book. Therefore, this section this section should be considered a requirement. There are two meson files, a cross toolchain file and the native toolchain file. There are different situations using either. So, required the package config personalities, well that's what we've just done. Creating the cross toolchain file, so we need to copy this. So this is all the parameters that would be used in a cross toolchain when running Meson, and likewise one for a native build as well. Native toolchain file. How to use the file, so it tells us how to use these. Again, all these instructions are in each package, so this just gives you information, I suppose, if you do want to install a package that's not in this book.